Okay, 21. Now look, before we do this problem, you guys need to understand, and which you already do just from having been alive, this concept of relative velocity. So see here the question says, what is her velocity relative to the surface of the ice? So this girl is standing on this plank, she's on this board, and she starts to move. The board is on a frictionless surface, so as she starts to move, the board's going to start to move. Like you can wrap your brain around this. Like, you know, stand-up paddle boards are now real popular. So imagine you're on a super smooth lake and you're standing on a stand-up paddle board. If you start to walk on the stand-up paddle board, you know, if you walk to the right, what's going to happen to the stand-up paddle board? It's going to go to the left, you know, because it's on a nice smooth lake. It's going to, you go to the right, the board's going to go to the left. Can you visualize that? Okay, now look, so relative velocity. So I always think about these moving sidewalks, which you've all been on. They have them at airports. So look at, if we talked about, so see this person standing right here? You know, we could talk about her velocity. What is her velocity relative to the moving sidewalk? 0. She's standing there, dude. She's just standing there on the moving sidewalk. But what is her velocity relative to the earth? Well, that would be whatever the velocity of the moving sidewalk is. You know, so motion is relative, right? Motion is relative. You know, you're driving on the freeway. Let's say you're going 60 miles an hour relative to the earth. There's a car next to you going 60 miles an hour relative to the earth. What's your velocity relative to each other? 0. You know, if you're driving next to a car that's traveling at the exact same speed as you relative to the earth, then your velocity relative to each other is 0. What if you're going north at 60 miles an hour and a car is coming at you south the other direction on the other side of the freeway, also at 60 miles an hour? What would be your velocity relative to each other? You got a car going, you're going north 60 miles an hour. Another car is coming south 60 miles an hour. What would be your velocity relative to one another? 120, right? 120 miles an hour. In fact, if you collided head on with that car, traffic investigators would refer to that as a 120 mile an hour collision. It's the same thing as hitting a wall going 120 miles an hour. If you hit a car coming at you, you know, 60 and 60. Anyway, that's relative velocity. Okay, so how do we do this problem? So this problem has some tricks. Let me erase this picture. So the first trick to this problem, they give you the mass of the girl. The mass of the girl is 45 kilograms, and she's standing on a plank that has a mass of 150. Now, not many kids would think to do this, but look, here's the thing. If you're standing on a plank like this, basically the mass of the girl becomes part of the mass of the plank because she's standing on the plank. So I'm going to say that the girl is M1, 45 kilograms. The plank is M2, which is 150, but you have to add the mass of the girl. Does that make sense? Because why? The girl is standing on the plank. So for all practical purposes, M2 is 195, M1 is 45. Okay, so what is the girl's initial velocity? Before anything happens, so V1 initial is what? 0, she's not moving. How about the velocity of the plank initial? V2 initial, before anything happens, what's the velocity of the plank? 0. Okay, so conservation of momentum, we can apply it here. This is, you know, I would consider this to be an explosion. It's like two things pushing apart. Because look, when the girl starts to walk, what's she going to, if she starts to walk to the right, which way is she pushing on the plank? To the left. As she starts to walk to the right, she's going to push on the plank to the left. So it's kind of like two objects pushing apart. So we can use conservation of momentum. M1 V1 initial plus M2 V2 initial is equal to m1 v1 final plus m2 v2 final. What is the total starting momentum? Does the girl have any momentum before she starts to walk? No. Does the plank have any momentum before she starts to walk? No. So then they tell us the velocity of the girl after she starts to walk, so that's going to be v1 final, is positive 1.5 meter per second. So sign convention here, to the right, we're saying to the right is plus, to the left is minus. That's our sign convention. Okay, so we are looking for v2 final. What's the velocity of the plank? That's what they want. Well, actually, hold on. A, what is her velocity relative to the ice? Okay, let's solve. Before we answer part A, let's just figure out what's the velocity of the plank after she starts to walk. So we're going to solve for v2 final. v2 final is going to be negative m1 v1 final over m2. So m1 is 45. v1 final is positive 1.5. And then m2 is 195 because it's plank plus girl. Okay, so this comes out as negative 0.35. Well, actually 3462. Hey, why does it make sense that this comes out negative? Because which way does the plank go? To the left. So that's negative 0.3462. We now have the velocity of the plank after she starts to walk. All right, so first question, what is her velocity relative to the surface of the ice? So basically relative to the earth. So you got to, the best way to do this is just imagine yourself walking on one of those moving sidewalks. If you are walking with a velocity of 1.5, but the surface that you're walking on is moving the other direction at 0.34 meter per second, what would be your velocity relative to the earth? You know, it's like when you're on a moving sidewalk. You've all done this. Have you? Raise your hand if you've walked against the moving sidewalk before. Kids, dude, I've seen my own kids do that several times. It's like part of being a young kid. Like, yeah, let's walk the other way. You know, and it's not like you walk and you get to the perfect speed where it's like you're not moving relative to the earth, kind of like you're doing the moonwalk or something. So look, are we going to add? Are we going to go 1.5 plus the 0.34 or minus the 0.34? We're trying to find the velocity of the girl relative to the ice. Is it going to be more than 1.5 or less than 1.5? Less than 1.5. So the answer to part A, you're going to go 1.5 meter per second minus the 0.35 meter per second, which gives 1.15 meter per second to the right. Okay? I don't know if I explained that well or not. Okay, B, what is the velocity of the plank relative to the surface of the ice? Well, look, this 0.3462 right there, that is relative to the ice, so that's the answer. 0.35 meter per second to the left. The velocity we solved for, that is relative to the ice.